A solid weighs 60 Newton in air, 50 Newton in water, and 10 Newton in oil. Calculate the density of the second liquid in kilogram per meter cube. Calculate the density of the second liquid in kilogram per meter cube. All right, so 5 minutes and I'll be with you, okay? All right. I'm sure you are true. Hello. Hello.
Hello, Mr. Dia.
Are we true? Hello, are you true? Hello. Can you hear me?
Yes, please.
What did we get?
Yes, please.
One by one. Let me hear from you. What did you get? Akosia, what did you get?
80 kilogram per meter cube.
80.
Yes, please.
Okay, a second one. A second one. Zuvia, Epia Watsma, Kelly, Amma, speak. Yes, Zuvia, what do you get? Hey, people are afraid to talk. Oh. Okay, so, pardon?
I was not able to solve it.
Oh, your line is breaking.
I said I was not able to do it.
Okay, so before we have other questions to solve, let's see. A solid weighs 60 Newton in air. So first, weight in air. Please mute yourselves. Okay, weight in air is 60. Then 50 Newton in water and 40 Newton in oil. So weight in water, we have 50. Then weight in oil, 40. The question is saying that calculate the density of the second liquid. Density of the second liquid. And what's the second liquid here? What's the second liquid here?
Oil.
So we are looking for the density of the oil. Okay. We have weight. We have weight in air, weight in water, and weight in oil. What can we find here? For this, the first liquid, and then the second liquid, it means that we can find the upthrust in water and in oil. We can find the upthrust in water, which will be equal to the weight in air minus weight in water. We can also find the upthrust in oil, which is also weight in air minus weight in oil. Are we there? Okay. So therefore, we can use the concept of relative density to find this. Okay. The weight of the object in oil over the weight of the object in water. Because the question is about a solid weighs. Okay. A solid is weighed in air, water, and then oil. So if we are using relative density, RD is equal to weight in oil divided by weight in equal volume of water. Okay. And weight in oil, weight in water is equal to upthrust in oil over upthrust in water. So it's just a question of substituting this. WA minus WW over WA minus W, sorry, O and then W in water. So put the values in to find the relative density. When you find the relative density, okay, relative density, it is equal to the relative density, the density of the substance or of the distance, yes, of the oil. Okay, you get the density of the oil. So you use density of oil, density of water, and you are good to go. Okay, so 60 minus 40, all divided by 60 minus 50. This is 20 divided by 10, meaning that the relative density of the oil will be equal to 2. Okay, this also implies that the density, once we have the relative density, it means the density of the oil, is equal to 2 grams per cm cube. Last time, I told you that numerically, relative density and density in gram per cm cube have the same value. Okay, so if once we have the relative density, it means we have the density of the oil. Okay, then the question demands that we find the density in kilogram per meter cube. And because 1 gram per cm cube is equal to 1,000 kilogram per cm cube, this is equal to 2,000 kilogram per centimeter cube. Akosia?
You said the relative density is equal to the density of the oil.
Relative density is equal to the density of the oil in gram per cm cube. Numerically.
Is the formula not relative density is equal to the density of the oil out of the density of the water?
Yes, that is it.
So the density of the oil is not the relative density times the density of the water.
Which is density of water in gram per cm cube is 1. It's 1. Are you okay?
Yes.
All that you are asking is true. That is it. But you see, yes, it's from here. RD is equal to density of substance The substance here is oil. So oil over density of water. The RD of the water is 2. And then the density of water is 1. Therefore, density of oil will be equal to 2 times 1 gram per cm cube. So it will be equal to 2 times 1 gram per cm, which is equal to 2. Are you okay?
Yes,
No,
please.
please.
And Mr. Okay, please. Mr. Elia, please. This question. Why didn't you use the upcharge of the oil to find the volume? Then
Oh,
you
it's a good question. You can also think around it. Okay. So I'll even want you to consider that, think through it. Okay. Use that approach to see if we can arrive at the same answer. It's
Mr.
a
Elia, I
good
didn't arrive
question.
at the same answer.
Pardon?
I didn't arrive at the same answer.
Meaning that perhaps maybe you erred somewhere. So just make time to review it for me. Okay. Okay.
Zedia, please. I can't see the other side of the board.
I'll adjust it. Akosia, okay.
Yes, please.
Mr. Elia,
Hello.
please, is this your final answer?
The final answer will be 2,000 kilogram per meter cube.
For density of oil.
Yes, because the question demands that we find the density of the second liquid in kilogram per meter cube.
Oh, okay.
Are you fine?
If
We'll
you
jump.
are
That,
Hurry up, we have 30 less than 30 minutes.
say,
Hello.
please, so the second liquid was not water, it was oil.
No, the second liquid is oil, not water. The first liquid is water. The second liquid is oil.
Okay, thank you.
Mr. Diaz,
Mm-hmm.
please, with the upcharge, I can't find the mistake.
Apusia, you have to look at it later and get back to me. Okay. You want us to do everything now. We have a lot of things to do. Okay. Huh?
Okay, sir.
It's a further probing thing you are doing. And in fact, I'm also appreciative and I like the approach. But do it later and then send your work to me so I can look at it for you. Okay.
Okay, sir.
All right. Let's look at a third question. This one is also on flotation. Maybe a last but one question. A hydrometer is made of a tube. A hydrometer is made of a tube of diameter 2.3 centimeters. A hydrometer is made of a tube of diameter 2.3 centimeters. The mass of the tube with its content is 80.0 grams. The mass of the tube with its content is 80.0 grams.
Mr. Dia,
Hello,
please, can you begin again?
can I?
Begin again.
Can I repeat?
Yes.
A hydrometer is made of a tube of diameter 2.3 centimeter. The hydrometer is made up of a tube of diameter 2.3 centimeter. The mass of the tube with its content is 80.0 grams. The mass of the tube with its content is 80.0 grams. If it floats in a liquid of density 800 kilogram per cubic meter, if it floats in a liquid of density 800 kilogram per cubic meter, calculate the depth to which it sinks. Calculate the depth to which it sinks. The X refers to the hydrometer. So calculate the depth to which the hydrometer sinks. Akosi, are you there?
Yes, please.
Zuvia, you've been quiet today. What's your secret?
It's no
Eh?
secret.
But you've been
There's-
quiet. Extremely quiet.
I'll talk.
So hydrometer is made of a tube of diameter 2.3 centimeter. The mass of the tube with its content is 80 grams. If it floats in a liquid of density 800 kilogram per cubic meter, calculate the depth to which the hydrometer sinks or it sinks. So give it 2 minutes to think through the question. Then we look at it. Okay. So 2 minutes for reviewing. Let's look at it generally. So it's about flotation. And what is the first condition for a body to float in another body or in a liquid? What is the first condition? Yeah, Zubia, what's the condition for flotation? Gloria,
The density of the body must be less than the density of the liquid.
fantastic. What's the second, the second condition?
The weight of the body must be equal to the weight of the liquid displaced.
Or the mass of the body must be equal to the mass of the liquid displaced. Okay,
Yes, please.
good. Thank you. So here he said a hydrometer. Forget about the made of a tube and its content. It's a hydrometer. Hydrometer floats, and once floats in liquid. Actually, hydrometer is used for determining relative density of liquid, the acidic content, the strength of the acid in batteries and all that. Okay, fine. When you determine the density for batteries, it will determine whether the acidic content is up or low. Okay, so it's a hydrometer. So the first thing is that once the hydrometer floats in liquids, then it means mass of hydrometer must be equal to the mass of liquid displaced. Short. Mass of liquid displaced is equal to density of the liquid times the volume of liquid displaced. Okay, because the hydrometer has a uniform cross-sectional area, let's the cross-sectional area of hydrometer be A. Then it means that its volume would be equal to the uniform cross-sectional area times the height of immersion. So it means that the mass of the hydrometer will be equal to density of the liquid times cross-sectional area of the hydrometer times the height of immersion. Okay. Hydrometer is like this. Cylindrical, meaning its cross-sectional area is circular. Are we there? Hydrometer,
No.
hydrometer is like the marker in my hand. It is cylindrical. Its cross-sectional area is circular. So when we talk about the area of the hydrometer, because it has a circular cross-sectional area, it takes the area of a circle. And what is the area of a circle? What's the area of a circle?
Pi r squared.
Okay.
So pi r squared in terms of diameter, what will it be? In terms of diameter, what will it be?
Pi d.
Come again.
Pi d.
No.
1/4 pi r squared. 1/4 pi diameter, sorry.
1/4.
1 over pi diameter.
Let's look at the relationship between radius and diameter. D is equal to
R square.
D is equal to
R
times
over 2.
2R.
is
2R.
2R. Good. Let's make R the subject. Right? Meaning, if we are given diameter, it is that the area becomes pi D on 2 squared. Are you with me?
Yes, please.
Yes, please.
So we have pi d squared on 4. So 1/4 pi d squared is the area when you are given the diameter. When you are given radius, this is it. If you are given diameter, this is it. Are we fine?
Yes, please.
Good. So it means the mass of the hydrometer can simply be equal to density of the liquid times the cross-sectional area now is equal to this. Pi d squared on 4 times the height of immersion h. Okay, finish it for me. I've given you all the tools to do this experiment. So go ahead and make me proud. Okay? Okay?
Okay, sir.
All right.
Okay, sir.
Mr.
Thank-
Elia,
Hello.
please, what will be the value of pi? Are we using 22 and 7 or the
And you
34?
use 22 and 7.
Okay, thank you.
Okay. Hello, finished? Hello, class. Hello,
Hello, Miss.
finished? So we have everything. I think the question gave us the mass of the hydrometer. The diameter of the hydrometer is 2.3 centimeter. Then the mass of the tube with its content is 80 grams. So mass of hydrometer (80 grams). If it floats in a liquid of density 800 kilogram per cubic meter. So density of liquid equals 800 kilogram per cubic meter. Please, and this is equal to 0. When we divide through by 1,000, 1, 2, 3, 0.8 gram per cm cube. Okay, and I'm converting because all other units are not in SI. That's why. So we have to calculate the height to which it sinks. The height to which it sinks. Once we are told that the hydrometer floats, then mass